Hello, I'm Mengkong Zheng from Taipei University of Technology. This study tries to know how can map design be more intuitively understood based on users' evacuation behavior. We were finally designing an evacuation interface. It also proved to be more effective in allowing users to move faster through the evacuation behavior experiments. Of course, I will introduce the whole process to you. When an emergency occurs in a public space, the most important is to find an emergency escape route. But in a closed underground space, it is not easy for users to understand themselves' orientation. Spatial knowledge is not easy to build. Therefore, there will always be serious casualties when disasters occur. At present, the standard practice for the station is asking attendants to guide people to escape. We wanted to see if we could use existing technology to help people move in emergencies. The advantage of IoT is that it can proactively push information to the mobile phone. So if we use this technology in the underground space, we might be able to change the limitations of finding information passively and take refuge in it on our initiative. So this study wants to understand the behavior characteristics, spatial cognition and movement strategy of emergency in underground space. Then through the underground space emergency experiment, summed up the user needs of content and a combination of push information. Then did a new design. Finally, using another emergency experiment to verify whether the new design can effectively meet the user's needs of emergency. We chose Taipei Station as our research base. Taipei Station is the most critical transportation space of 3 railways in Taiwan. It is also the largest railway station in Taiwan. The number of daily interchange passengers is about 500,000, ranking 25th in the world regarding the total number of passengers. To understand the behavior of pedestrians seeking refuge in underground space, wayfinding experiments need to select a section of the route to observe and record the various reactions and problems of passengers in the escape process. However, the routes inside the Taipei station are complicated, so according to the conditions of the crowd, the moving line, the distance, the number of escape signs, and the complexity of the space, the most challenging escape rate in Taipei Station was chosen on the floors to simulate the experiment of pedestrian escape. 16 subjects participated in a simulated escape experiment. The study recorded the subjects' walking time, speaking content, viewing indicator items, stopping place, and walking route. Think Aloud was used to record the subject's feelings and thoughts at the moment of the experiment. We found that the subjects were most likely to be confused and hesitated at the turn-off, with a total of 54% of the subjects hesitating and confused. The other are cross-floor, 22%, and exit gate, 16%. So we know that the location of the IoT device to push the escape message needs to be considered in these locations. There are several reasons why it is easy to be confused when you turn a fork. Under the pressure of the experimental time, the subjects could not get the information they needed quickly, so they had to spend a long time staying here and looking at it. Subjects in the long path of movement. It is not easy to read the distance sign content. Escape sign does not allow people to see the location at a glance. Other complex sign information also enables the subject to ignore the escape sign, thus prolonging the completion time of the task. From this 3D map, it's easier to understand why these places that are prone to confusion. There were fire and smoke at the Taipei station. The most time spent grooming is in these places. Then, we analyze the existing navigation interface app through the eye tracker to understand the user viewing hotspots. Interview subjects to know the user for each interface version preference. Through the above 3 stages, summed up the design conditions of the interface, and then carried out an evaluation experiment to verify the design. We collected 20 existing navigation interface cases with high user ratings based on the App Store, analyzed the area of each information field based on the interface information in navigation mode. There are the north arrow, current location, map, information field, navigation field, function menu, and the function key. Then K method, K means, is used to group each combination. We looked at the scale of the area of each element of the existing interfaces, tried to rearrange them into a new combination to be some models for future experiments. Finally, the interface format of the 5 groups is obtained, and the arrangement of different groups in the 5 interfaces is entirely different. We took them as the experimental sample. We asked 16 subjects to perform eye movement experiments on these 5 different interfaces. We stacked the skimmed parts, and the higher the saturation, the more focus the users have. We found that the visual scan range of the interface was higher in the map and route, which showed that the map and route were the information subjects more concern. The navigation bar of the interface is viewed more frequently than the notification bar. The subjects were then asked to rank the 5 interfaces based on their preferences. The results indicated that the interface sample A is the best. Most of the subjects thought the interface scale was just right and easy to understand and read, so we will also use interface A as the new interface design version. The interviewees mentioned that compass, floor function, and zoom were less helpful information. They can't understand the icon of floor function. The information that the participants thought was missing included the distance and location of the disaster area, the location of the firefighting equipment, and the distance left from the exit. To understand the help of viewing the functions of the interface to escape, we used the Likert scale to ask the subjects to evaluate each function of the interface one by one. As a result, the function of the interface that the subjects considered most helpful to escape was question 2, cross-floor diagram. Besides, the subjects believed that only one escape rate on the interface would be sufficient. Subjects paid less attention to functions other than escape guidelines. Missing information that users said includes distance from exit, fire location, turning distance, escalator or staircase, and fire equipment. The interviewees said that they cared about whether the map could tell where they were relative to other landmarks on the map, and whether the map could see the overall escape route. Here needs to mark their position to determine their location in space. Navigation bar steps need to be clear and precise. Notification bar needs to let the users know the next and final target. Besides, most participants said that return to the present location and compass to escape help little. So we designed an interface design using the color of red and orange with a cautionary effect. The target exit prompts the person to escape with a text narration. The escape steps are presented vertically, and the push shows the current and next instructions. The color is grayscale. The walking range is in light gray, and the non-walking range is in dark gray. The line clearly distinguishes the different floors. The current location, route, and cross-floor cues are presented in sharp colors, mainly to separate the map from the route. Add a graphic turn icon in the course of a turn. We integrated the compass with the ability to return to its current position and design new functional symbols. The placement of space hardware facilities in the interface, such as elevators, bathrooms, escalators, etc. Add a graphic representation of the fire extinguisher to the map to enable the escapees to know the location of the fire extinguisher in the field. After the UI was imported into the mobile phone, this study carried out emergency experiments, a total of 32 people. The code was coded according to the behavior of the subjects in the experiment. The classification of coding is based on the 3 stages of wayfinding behavior proposed by Passani, including gathering information, decision-making and decision execution. At M7 exit, the number of times of code IPR, means viewing map routes, is the highest in the category of gathering information. The maximum number is coded DDC, means choosing a accessible route. In the decision-making, the highest number is coded, means questioning decisions, in the category of decision execution. At M8 exit, the number of times of code IPR, means viewing map routes, is the highest in the category of gathering information. The maximum number is coded DDD, means following a pathway. In the decision-making, the highest number is codel, means taking the escalators, in the category of decision execution. Most subjects immediately choose their way before crossing floors. Hesitation occurs at corners, including B3 before and after escalators across B2 floors. Subjects also referred to the movement of the population as they used the app. At the turn, they saw a left turn icon on the phone's interface that followed the corner and followed the flow of people. After 2 stages of interface design, experiments and interviews, we revised the design proposal. We made some changes. From the interview, the subjects in the escape process pay less attention to the information of the target exit, or cannot know that it is the target exit. Therefore, this study simplifies the original more lengthy narrative. The subjects suggested the addition of landmarks. Thus, the 2.5D map was added to the design, so that this form of the map can be more in line with people's cognitive map. Finally, correct the curve diagram at the turning point of the route to avoid confusion between the turn icon and other icons in the map. Most subjects in the interview said that the location of the fire is essential escape information. In the revised design proposal of this study, it is attempted to make the indication of the fire starting point more explicit and to use a graphical fireball icon to indicate the fire starting point, show a strong warning effect, and convey clear information to the escapee. When there was a fire at the underground station, the user's phone will jump out of the alarm message first. Then you can choose the guide. There will be new interfaces to guide people to move. The following is an introduction video.
Wayout is a fire escape guidance service for underground spaces. If a fire breaks out nearby, Wayout will immediately provide a push notification of the escape information to your cell phone. To help you search for the nearest escape exit, it will start to navigate, telling you how to stay away from the fire source and get out safely. When an emergency hazard takes place in a public area, the first thing people need to do is quickly locate the emergency escape route. However, in a sealed-off underground space, quickly locating the direction of movement can be difficult. Some reasons include bad reception, complicated space, and unfamiliar with the space. In the past, safely escaping mostly relied on the assistance of station staff. Now, one can use the current technology to assist people during an emergency escape. Wayout is a programming design that best complies with visual design standards for underground space escapes. Having analyzed different case examples of the escape interface, we proceeded with testing the most representational interface proportion. 2 Step 1 Exit. The screen displays 2 guiding steps for the escape and 1 guiding message for the exit. And the configuration can let the user focus on the first step and also shows the user the next step in advance. Turn tips. The turn tips symbol is placed on the escape route, so the user knows that there is a turn ahead of time. 2.5D Navigation Map. In seeing a navigation map, people first search for landmarks. Therefore, using a 2.5D map can help the user quickly identify the environment. Environmental facilities. The facilities can assist in confirming the position where they are located. Therefore, we especially mark elevator, column, restroom, which users can have a better impression on the map. Next floor tips is an important foundation for the escape in the case of an emergency fire. At the end of the route, placing the crossing the floor symbol can assist the user to determine when they need to go to the next floor.
Thanks for your attention.